Alright, so today I'm going to talk about the development of conversation agents in mixed reality. So actually the idea of a conversation agent isn't exactly brand new, but with the rise of large language models, which so-called LLMs, and the performance of these agents has improved a lot, and there are already many mature chatbot applications out there on web or even on the phone application. But what happens if we bring the concept of a conversation agent into mixed reality? So to start off, let's take a look at a quick demo.
Hi. Hello, how can I help you today?
Help me pick a random number from 1 to 10.
Sure, here's a random number. 7.
你可以跟我用中文交谈吗？
当然可以，你想聊些什么呢？
Alright, so from the demo, we can notice that in mixed reality, the agents can appear in much more flexible ways, and compared to the traditional UI interfaces, which gives us a more immersive and interactive experience. And then we can further break down the agents into two main components, the embodiment layer and the conversational core. We can say that the embodiment layer refers to the agent's visual appearance and body movements. In simple words, it's just like giving a body to AI. While the conversational core is what powers the logic and the content of the conversation itself. And this is essentially the LLM that drives the agent's dialogue. So in this course, for our development and the hands-on practice, we'll be using the Meta Avatar SDK and OpenAI to represent the embodiment layer and the conversational core. Okay, so here's today's outline. And first, I'll walk you through how to use the Meta Avatar SDK and how to control your avatar using the Unity animation system. And then at the end of the session, I'll briefly go over how to integrate an LLM into your project. So let's start with Meta Avatar's SDK. Alright, so to use the Meta Avatar SDK, you should first import it from the Unity Asset Store. And it is just like what you have done with the Meta All-in-One SDK in the first assignment and your midterm project. So what you need to do is just find the asset in the Unity Asset Store and click the button to add the asset to your account. And next, you should go to your project, and you can find that the Meta SDK in your package manager. And for this class, we'll be using the version 35.0.0 of the Meta Avatar SDK. And it is important to note that the different version of the SDK can vary quite a bit, so please make sure you are using the correct version to avoid compatibility issues. And also, since that the Meta Avatar SDK development often relies on some of the assets provided in the sample things, so you also need to import the sample things from the package manager. And you can find the sample things by clicking the samples on the panel in the package manager, and then you can easily import the sample things into your project. Okay, so let's get into the avatar part. And this project setup is to use the avatar manager. And anything that uses the Meta Avatar needs to have an avatar manager in there. So it handles things like rendering the avatar skin and also some tracking input. Well, you don't need to build one avatar manager by yourself, and we can simply use the preferred asset provided in the sample scene. And you can find it by following the file path shown in the picture, or you can just type the Avatar SDK manager in the search box, in the Unity search box. this prefab will be in the sample scene I just mentioned earlier. And once you find it, you can just drag the prefab into your scene. Alright, so let's go to the avatar itself. And I'll first talk about the sample avatar. The Meta Avatar SDK have provided several sample avatars that you can use locally in your project, and I'll show you how to use it. So first, you'll need to start by creating an empty GAN object in the Unity. Then you should add the sample avatar entity script to the GAN object you have created. And to do this, you can just click the Add Component button and search for the sample avatar entity script. And then there's some settings for the sample avatar. And the first one is that you can change the active view of the avatar. And there are two different active views. One is the first-person view, and the other is the third-person view. While the first-person view is usually used for representing the headset user's body. Like when you are using the headset, there's no need to show the head of yourself, since you cannot see it. And for the third-person view, it is the full-body avatar. And you can change the active view of the avatar based on your requirements in the project. Okay, so except for the active view, there are some other network settings. Like here, the networking refers to whether the avatar entity is a local avatar or if it should load data from the network. And for this course project, I think using a local avatar is more than enough. And so make sure to check the is local box. And there's also an option called load user from CDN, and which controls whether the avatar's appearance is loaded from the cloud. And since in this sample avatar, we are using the sample provided by the Meta, so you should uncheck this option. And as for the sample avatars, the Meta Avatar SDK actually provides multiple different skins that you can choose from. And if you want to change the skin of the sample avatar, you'll need to add the new elements under the assets section, and then set the path index number. And this number tells the system which skin file to load. So currently there are 33 sample skins available, and so the index range should be 0 to 32. Alright, so it's pretty much it for the basic data of the sample avatar. And now I'm going to talk about how to create your own custom avatar. And aside from the sample avatars, one of the biggest advantages of the Meta Avatar SDK is that it allows you to easily create your own custom avatar and use it directly in your application. So to use a custom avatar in your project, the first step is to create your own avatar. Okay, so to use the custom avatar in your project, the first step is to create your own avatar on the Meta Horizon app. So you should download the Meta Horizon app on your phone, on your smartphone. And that's after downloading the Meta Horizon app, you can log in with your developer account. And once you are logged in, you can create your own avatar on the app. And you are free to choose the clothes, the hairstyle, and any other else about the appearance. And the one thing you have to notice is that you have to make sure the account you're using is registered as a developer account. Otherwise, you won't be able to use the avatar in your Unity project. Okay, so the next step is that after you create your avatar, you should go to the Meta Developer Dashboard website to create apps for your project. And this will allow us to link the custom avatar to our Unity project. So on the dashboard, you can click the green button on the top right corner to create a new app. And there are two types of apps that you'll need to create. One is for the Meta Horizon app, and another is for Link, the PC VR. And the setup process is the same for both, so you'll just need to repeat the following step twice. Okay, so after creating the app, you should go to the requirements section on the left-hand menu and click on the data use checkup. And we'll need to request the permission for three things, which show on the screen, like user ID, user profile, and the avatar. And you can just click add to add a permission. And after clicking add, you will be asked to provide a reason for requesting each permission. And you can just fill in something simple words, and you can also follow the example shows in the slides. Like for the usage, you should choose the used avatar, and for the description, you can just fill in like testing avatar in Unity. And once you have filled everything out, just click the submit button on the right top corner, and you'll further need to fill in some question of the app authorization. And after you submit the request, Meta will then review your permission request. And in my experience, it's usually get approved in a short time, maybe within an hour. So after the permission are approved, you should go back to the dashboard and find the app you just created. And one thing you have to notice is that you have to make sure you are looking at the correct app type, just showing under the bar. And it might be either be Meta Horizon Store or Rift. The Rift means PC VR. So then you can click into your app, and on the left-hand side of the menu, you can look for the API section, and then you can find your app ID there. And next, we should move to the Unity project settings for the custom avatar. At your Unity project's top menu bar, you should go to Meta Platform Edit Settings, and here you'll need to paste the app ID we just mentioned, you just got earlier. To be careful that there are actually two different apps IDs, and so you should make sure you are passing the correct one into the right field and do not mix them up. So, alright, basically, let's talk about the avatar entity settings. And most of the setup is the same as with the simple avatar. Like you have to create an empty game object, and you should attach the simple avatar entity script to the game object. But this time, you should have to make sure to check the box of load user from CDN. And this will allow your project to load the custom avatar you just created using the Horizon app on your phone. So on the picture, you can see that this is the custom avatar of my account. Okay, so up until now, we have been talking about how to set up an avatar in your Unity project, but the avatar we have noticed so far are just in the T-pose, like the picture like that, and which is usually the default rest pose of an avatar. So next, I'm going to talk about how to actually make your avatar move. So it is not just stuck in a T-pose walking around the scene. Alright, so in the Meta Avatar SDK, there are two main ways to drive an avatar's motion. The first one is avatar input tracking, and the other one system is the animation behavior. So, Okay, so for the input tracking, as the name suggests, means that tracking a person's real-world movement and reflecting those on the avatar. So you can think of it like having a digital version of yourself in the VR or AR world that mirrors your motion in real time. So this method uses the live tracking data to drive the avatar. Okay, while on the other hand, the animation behavior is a different system, and it allows you to drive the avatar using the pre-made animation rather than using the real-time tracking. So for today, I'll briefly touch on the input tracking, but mainly going to focus on the animation behavior, since that is more relevant to your upcoming assignments and your final project. Okay, so let's first take a look at the input tracking. And if you want your avatar's movement to be driven by the headset's tracking data, you'll need to make sure there's a sample input manager in your scene. And the good news is that you don't need to add this from the scratch, since that the script is already included under the avatar manager object that we just set up earlier. So as long as you have added the sample avatar manager prefab, you are ready to go. And then the things that all you need to do is to drag the avatar SDK manager object into the input manager field. And the field is under the tracking input section of your avatar sample avatar entity script. And once that's set, your avatar will start to move based on the motion data detected from your headset, so that the head, the hands, the body will follow your track movement. Alright, so the next thing I want to talk is the lip sync input. And you can imagine that if your conversational agent is talking to the user, but the avatar's mouth isn't moving at all, and it is going to feel super weird and totally break the immersion. So that's why the Meta Avatar SDK provides a lip sync input system, and which allows the avatar's mouth to be driven by the audio input. So when your agent speaks, the avatar's mouth will automatically move in sync with the voice, just like you can see in the top right image there. And using the listening input is actually pretty simple. The first thing you need to do is to, like the avatar entity, you have to create an empty GAN object. And then you should add both the lip sync context script and the audio source component to it. And this way, the lip sync context will generate this movement based on the audio from the audio source. And one thing is that you can also choose to drive the lip sync using a microphone input, but for our implementation, we'll mainly use the audio source to control the lip sync. So with the audio source, you can simply assign any audio clip you want to your. You can simply assign any audio clip you want to drive your avatar to speak, and then you can just drag the object you just created earlier to the listing field under the tracking input section of the sample avatar entity script. And once that's done, your avatar's mouth will automatically move in sync with the audio clip. And this will create a more natural and believable speaking animation. Okay, so that's pretty much it for the tracking input part. And what I'm going to talk about next is the avatar's animation behavior. And basically, how we can use existing animation to drive the movement of the avatar. Well, the Meta avatar actually supports 3 different types of the animation, which are default, custom, and hybrid. But today I'll only focus on the custom animation, since that the other 2 are really related to your assignment or final project. So if you are curious though, you can also check out the Meta's official documents for more details. Okay, so the first, if you want to use the Meta Avatar SDK's animation behavior, you'll need to add the need to add the animation behavior script to your avatar's entities components. And this is what allows the avatar to actually be driven by the animations. Okay, so next I want to talk about the custom rig prefab, and which is a really important part of the animation behavior system. And you can think of the avatar we created earlier as something that has just the skin but no skeleton. But in animation, the idea of a skeleton or the rig is super important. That this is what we use to drive the movement of the skin. And when we have different characters, as long as they share the same skeleton and animation, they can perform the same movements. So in this case, you can think of the custom rig prefab here as the skeleton of the Meta avatar. And okay, so to set the prefab up, we'll be using the resources from the sample scene, we just mentioned at the opening. And you'll need to find the custom rig prefab in the sample scenes in the past, like just shown in the image, and then create a new prefab variant based on it. And to create a new prefab variant, you can just right-click on the prefab you just find. The prefab is called humanoid avatar rig variant custom animation only. And you can just right-click on this prefab and go to create prefab variant to create it. And the second step is that once you have created the prefab variant, you'll need to move it to the resources folder in your Unity project. And the reason why we have to do that is that the Unity automatically loads everything in the resource folder at runtime, but it doesn't do this for other folders. And since that the Meta avatar system requires the prefab to locate it inside the resource, so it will not work properly if you leave it to somewhere else. So you should make sure to put your prefab into the resources folder. Okay, the last step is that you just need to drag your prefab you just set up into the animation behavior components of your avatar entity. And with that, your basic rig setup is complete. Okay, now let's go over some of the custom animation settings on your OVR avatar animation behavior script. And basically, all you need to do is just check the custom animation only and uncheck the input blended. While the custom animation implies that only using custom animation rather than using the default animation, while the input blended is a feature that allows you to use the tracking input for upper body while keeping the animation for the lower body. So we can think that the input blending is the blend of the tracking input and the animation behavior. But since we are only use custom animation here, so we won't need the feature. So make sure the input blending is on track. Alright, so now let's talk about how we can actually control the meta avatar rig. That is, how can we animate the avatar? That the meta avatar animation behavior allowed us to use the Unity's animation systems to control it. So the first step we need to do is to create an animator controller in your assets and then assign it to the animator components on the human avatar rig. And once that's done, you can use the Unity's built-in animator controller to drive your avatar's movement. Okay, so since we'll be using the Unity animation system to control the avatar, so I'm going to give a quick intro on how it works, how the Unity animation system works. And there are actually two main components we will need to know about. That the first one is the animator controller, which we just mentioned, and it's used to manage and switch between the animation. While the second thing is the animation file itself, which is usually in the FBX format. So let's start by looking at the animator controller. And once you click and open it in your project, you'll see an interface that basically works like the simple state machine. And the state machine is used to control the state of the animation, and you can set up and manage the state machine using the panel on the right. And also in the panel, you can create different states, and for each state, you can assign the specific animation clip. And when the controller enters a certain state, the assigned animation clip will, the assigned animation for the state will start playing. And you can also fully define the rules for the state machine. Like, all you need to do is just add the transition at the panel on the right. This will let you decide when or how the animation should switch from one to each other. Okay, so the next component is the parameters. And in the animator controller, you can also set up the parameters to help the control transition between the states. And the advantage of the advantage about using parameter is that they can make it super easy to control transitions through the script, which is your C# code. And for example, like let's say I want an avatar to switch back to the idle state when they are not speaking. So I can do this by adding the condition to the transition. Like you can see on the left side that there's the condition section, that you can add some rules for this transition. And then you can add the parameter to this condition. Like I want it to back to idle state when the parameter is talking is false. So you can use another script to update the parameter's value. Like in this case, it's talking. I can use my code to set the is talking parameters to false, and this will trigger the animation to change automatically. Okay, so we just talked about the animator controller, and now I'm going to introduce the animation itself. Like in Unity animation system, the FBX file format is the standard file format used for 3D animation. And FBX file and even an entire scene. So There are actually different types of animation, and one of the most important types we have to mention today is the humanoid animation, and which refers to the specifically to animation for human-like skeletons. And since that the animation we'll be using in the class are for the avatar, so we are focusing on talking about the humanoid animation from here on. And we can see in the picture that in Unity, a basic humanoid animation setup typically involves 3 components. The one is animation clip, and second is Unity avatar rig, and the next one is the model. So let's start to talk about with the animation clip. And the animation clip stores all the keyframe data, and just like the picture shown on the screen. And the idea of the keyframe is pretty simple, like it marks where each joint of the rig should be at a specific run, and including its position and even rotation. And you can see in the image that each of the small dots in the image represent the keyframe data of the joint. And next is the model. Well, the part of the model is pretty straightforward, that is basically the 3D character model. And in the model, it usually contains the skin and the skeleton of the model. So it decides the appearance of the model. Alright, so the last component is the Unity avatar rig. Okay, so you might have a question about what do we need the avatar rig, since that it seems like owning the clip and the model we just mentioned is enough for a 3D animation. Well, it's actually related to the humanoid animation. In a normal situation, when you have to create an animation, it's built specifically for only one model. So if you want to apply the animation to different model, you will have to rebuild all the keyframes for that new model, and which will be really time consuming. But since that most of the humanoid model, like human-like skeletons, are structurally similar, so like they all have the things like the shoulders, the necks, the elbows, something like that. So Unity humanoid animation system make it possible for the models with slightly different skeleton to share the same animation. So you don't need to have to rebuild your model. You just need to convert it to a humanoid animation, and then the other human-like skeleton can use the animation from another model. And what the Unity avatar rig does is basically map the specific joint of your model to a standardized humanoid rig, so that the Unity knows which part is which. Like you can see in the picture. You can see in the picture that this is an example of the avatar rig, and you can see there's a joint map to the hips, and there's a joint map to the spine. And this is how the avatar rig works. Okay, so now that we have talked about the animation file, and you might be wondering that where can we actually get them? And there are lots of few resources online, such as Mixamo, Actor Core, and also the Unity Asset Store. But this. Okay. So for this kind of resource, like the online resources often come with some limitations, like it might not perfectly match to your need. So alternatively, you can also create your own animation or modify your own animation using the tool like Blender or Maya. However, we don't recommend you to do this for this course. unless you're already very familiar with these kind of tools. Okay, so once you have get your animation file, you'll need to configure it inside the Unity so that the Meta Avatar can actually use it. And the first step is to import the animation file into your Unity project. You can just drag it or copy the animation file to your project. And next, you'll need to change the animation type from generic to humanoid. And you can modify it by clicking the FBX file, and after selecting the humanoid type, you can just click the apply. So in this way, the animation will automatically convert it by the Unity editor. So you don't have to convert the animation manually by yourself. Well, the step is really essential that without converting to humanoid, the animation will not work correctly with the Meta Avatar. So you have to make sure to convert your animation type before using it. And once it's converted, you can just drag the animation clip to the state you want in the animator controller. Like in the example, I just dragged the idle. I just assigned the idle animation clip to the idle state, and in that way, when controllers switch to that state, the animation will be played automatically. So here's a simple example of using an animation to drive the Meta Avatar movement. And as you can see that the Meta Avatar is able to reproduce the same motion as defined in the animation file. The left-hand side is the animation file, while the right-hand side is the Meta Avatar. And okay, so that's pretty much wraps up the Meta Avatar SDK overview. And here's some useful learning resources you can check out if you are curious or you run into any issues. Okay, so far, I think, does anyone have any questions? If no, we maybe can have a 10 minutes break. Okay. And we know that nowadays running a language model locally usually requires a lot of computing resources. And so the common approach today is to use the API for using the large language model. Okay, but what exactly is an API? That you can think of an API as a bridge that allows different applications to talk to each other. And as long as both sides follow the predefined format for sending and receiving data, they can communicate to each other. And the bridge is what we call an API. So if we want to use the LLM in our project, the overall workflow will look something like this. Like the picture, that your project will need to send a request to the LLM provider via an API, and then the provider will send back a response generated by the language model in the same way. Okay, so what exactly do we need to send when calling an API? Well, that depends on which LLM provider you are using. And each provider might have its own API documentation, but the overall structure is actually very similar across the board. So since that the template we are going to use in this class is based on the OpenAI, so I'll walk you through an example using REST API to send the request to OpenAI LLM with the C# code. And you can find that when you send the request to OpenAI API, there are typically 3 key components you have to have. And the first one is the endpoint. That the endpoint is basically the URL you are sending to the request to. And just like how a letter needs how the letter needs an address to be delivered. So, for example, when using the OpenAI's chat models, the endpoint will look like something like the URL on the screen. And the second thing you have to include in your request is the headers. The headers actually contain important metadata, including the authentication information. And since most LLM services are paid, so you typically need to include a valid API key here to prove that you are authorized to use the service. And the next one is the body part. And this is where you include the actual content of your request, like we so-called the prompt. So that includes the prompt and the message you want to send in the model. And you can also send some settings like the model name and sometimes extra parameters like temperature or the role-based message. And okay, so but what you can exactly include the parameters, it depends on. Okay, so what you can exactly include in this body part is depends on the provider's API documentation. So you should check. So in our case, we should check the OpenAI documentation. All right. So after you send the request to the LLM provider, you will receive a response from the provider, and inside the response is where the model's replies will be. And typically, the response comes in a JSON format, so you'll need to parse the JSON in your C# script to extract the model's reply. And in a simple case like this example, the response from the LLM will be found under the content field. Like in the example, the reply will be, "This is a message from AI." And there's also another important concept to keep in mind that if you want the LLM to respond based on the entire conversation context, like our normal chat, you can do like the normal chat you chat with ChatGPT, something like that. And you have to if you want that, you need to maintain a chat history. That means that okay, so that means that keep tracking of the full conversation so far, and including in the you should include all the conversation as a part of the next request you send to the LLM. So yeah, but this is basically the most fundamental way to use an API to have a conversation with an LLM. Okay, then next, I'm going to show you some tips that you might be used when prompting. And the first one is the concept of system prompt. A system prompt is essentially a way to define the role and the behavior of your AI assistant. And you use it to clearly tell the LLM what kind of the task it's supposed to perform, so that it can respond more accurately and appropriately. So, for example, you can see you can see on the screen that I want that LLM to act as a tutor. So I can use the system prompt to tell you that you are a helpful and knowledgeable smart tutor, and you should answer the student's question in detail and patiently. So in this way, that the system prompt can help guide the model's behavior and set the expectation for how it should respond. And the next prompting tip is something called structured output. And this is a very useful technique that makes it easier to work with the content generated by the LM. And normally, when you use an LM, it just gives you a big block of plain text, and if you want to extract or process the string, and which can be really time-consuming and error-prone. So that's why we use the structure output. That with the structure output, you can instruct the LM to respond using a defined format like JSON or bullet points or a table. So it only returns exactly the data you need in a structured way. So, for example, you can see on the screen that, let's say I want the LM to help me summarize the academic papers, and I want to know things like the authors and other key metadata. So if I just ask for this in a casual way, the LM might return a long paragraph that's hard to parse. But if I use the structure output prompt, I can ask it to respond in a format like, you can see on the screen that like the left side is the prompt. Like I told the LM the response should be in the JSON format, and the properties should have the title. The title should be a string, and there also should be a properties like authors, and the authors is a array of strings. So in this way, the response of the LM the structure output response will be like the right-hand side, that we only produce the essential data that I need. So this will make it much easier to work with the data in the code to pass, when you have to pass it to other systems, it will be much easier. Alright, so up until now, we have been talking about the basic way to use an LM via API. But next, I want to introduce another type of API, and which is also part of OpenAI services called real-time API. So what's the difference between this and the regular GPT API we just have mentioned, and why do we need this? Alright, so well, in our conversation agent, we wanted to be able to talk to the agent using voice in real time. But if we use the standard API, the regular GPT API works kind of like this. Like you send a request, it processes, and it sends you a response. This is simple, yes, but not fast enough for the live interaction. And there is often a delay, like if you can imagine like you say something and then you maybe have to wait 30 seconds for a response. And that's obviously not ideal for natural real-time conversation. And that's where the real-time API comes in, that it's OpenAPI speech-to-speech LM API, and which led us to talk to the model and get the immediate response, like a real-time conversation. And since for this project we want to support live dialogue with our agent, so we'll need to use the real-time API to handle the real-time communication in our application. So I'll give a brief intro of the real-time API. And the real-time API, according to the OpenAI's documentation, it supports both text and speech transmission. And the reason it can achieve a real-time performance is because it uses the WebSocket or the WebRTC for network transmission. And this kind of protocols are designed for low latency and real-time communication. Well, now we are not going to go into the technical details of the WebSocket and WebRTC today, since that we are not a networking course. But if you want to use the real-time API in your own project, you'll need to know how to establish a connection and send or receive data using this kind of protocols. And in the template we provide, we use the WebSocket as the transmission method. Yeah, we will establish a real-time API in a template so you can directly use it. And while the main difference between the WebSocket and the REST API is that the WebSocket creates a persistent connection. And you can imagine that once the connection is connected, and it will allow the continuous two-way communication. And unlike the REST API, which follows only a one request, one response model. So if you're planning using the real-time API for your agent's communication, and make sure you understand how the WebSocket works and how the data flow is handled through it. So for your upcoming assignment and final project, we don't expect you to spend too much time setting up the underlying architecture for the real-time API. So yeah, just as I just mentioned, that we will provide you with a pre-built template that already handles the integration with the real-time API. And while the only part you might need to modify is the system prompt used by the real-time API. Yeah, that's a little bit different to I just mentioned for the normal GPT API. And just like with the regular API we talked about earlier, and you can provide some instruction or context to guide the language model's response, and even in the real-time voices interaction. So the instruction in the example is like, I want the model to provide a transcript, and I hope it to only speak in English. So this kind of instruction will be embedded into the conversation. And in this way, you can customize how the agents behaves by simply adjusting the system prompt, like the instruction you showing in the example. Alright, so that basically covers the entire part about integrating the LLM with your conversation agent. And just like before, we have provided some learning resource here. It's basically some documents by OpenAI, and which you can refer to during your development process. And that's pretty much it for this section of the course.